Welcome to our demonstration of SOLIDWORKS 97 Plus, the new standard in Windows-based solid modeling. Why are we the new standard? Well, our customer tells us because it's three things. One is we're a production-level solid modeling tool. That means they're able to fully define their designs and effectively use them in downstream applications. Two, it's a native Windows application. So not only is it a familiar user interface, but they're actually able to communicate the designs much more easily because of standards available in Windows. And three, we've priced it so that every engineer and designer in their company can take advantage of this functionality in their company. Let's talk about a specific customer. In this case, we're going to talk about Life Fitness, best known for their Life Cycle exercise equipment. They came up with a brand new design called the Crosstrainer. And since they were hit with a very, very tight deadline, they decided to use SOLIDWORKS to make it. And not only did SOLIDWORKS enable them to meet their deadline, but the design was so much better than they originally anticipated that they were able to triple their sales forecast for the following year. What we'd like to do is we want to show you how companies like Life Fitness can take advantage of the functionality within SOLIDWORKS. So what you see on the screen right now is the Crosstrainer design that's been done in SOLIDWORKS. And what we want to do is we want to focus on two areas in the design. We're going to start in the console area. Now before we do that, look at the SOLIDWORKS user interface. Okay? It's a standard Windows application, complete with things like dockable toolbars, drop-down menus. Over on the left-hand side of the screen, you see Joe working with the Feature Management Design Tree. This is a very important part of our user interface. You'll see how that works a little bit later on in the demonstration. Now what we want to do is, let's focus again in on the console area of our Crosstrainer. And we have a very prismatic or simple looking panel there, and we want to replace it with a more stylized one. So Joe's going to start by using configuration tools. And this is our large assembly management tool. It lets us simplify very, very large assemblies. But here he's simply going to turn off the console, and we're going to replace it with a brand new one. Now let's start our session in SOLIDWORKS very simply. We're going to create a brand new empty part and start building up our part as a series of features. Now, SOLIDWORKS is a feature-based solid modeling system, and what that means is you build up your design as these intelligent building blocks. Joe is going to start by creating a 2D profile. These profiles can be extruded, swept, revolved, lofted to create a solid feature. Watch as the sketching tool helps Joe create his 2D geometry. In this case, he's sketching with mirroring on. What that means is as he sketches one side, the other side is automatically mirrored or created for him. Watch as it tells him when curves are attached to one another, whether they're at endpoints or on the curves, okay? Helping him every step of the way. Now, this is a design tool, and engineers need many different ways to modify their design. To do that, one of the tools available to Joe is he can grab any vertex in the design and drag it around with the mouse. This is great for conceptual design. Once Joe's satisfied with the profile, he can now take it, and as he's done here, he's extruded it to give it depth. Now, this again is a design tool, and we want to give our customers a number of different ways to edit the design. Joe can simply go back and select on the feature with the right mouse button and return to the sketch. Here he can drag it around and again continue to make modifications and then update the design. We'll go back in and edit that sketch one more time, and another way we can control it is not only can we drag it around with the mouse, but let's add parametric dimensions. These give us a way to provide very exact sizes and locations for our features. So Joe is starting by adding dimensions to control the curvature on the sides and the top of our console. Watch as he modifies the values of the dimensions, and you'll see the geometry react or update to reflect the changes that he specifies. Next, we're going to add dimensions for the width and the vertical height for our console as well. And again, as Joe makes modifications to those dimensions, not only now, but any time in the design process, you're going to see the geometry of the part update to reflect that change. Once Joe's satisfied with the modifications, he'll exit that sketch and the solid feature's been updated. Now, a very important part of the SOLIDWORKS solution that we provide is the third-party applications that work right along with SOLIDWORKS. Let's say as we're working on our design, one of the things we want to do is we're working with very standard components or electronics for the display LED. So Joe is going to retrieve a previous design. To do that, he's going to do a search of our archive or database right from the SOLIDWORKS menu structure. But the thing that's significant here is he's actually firing up a third-party application. In this case, it's SmartTeam, a PDM system. So what Joe has available to him is full-blown PDM, complete with vaulting, rev control, workflow, okay, all within the SOLIDWORKS environment. What Joe is doing right now is he's searching for any SOLIDWORKS documents that have the the words console in their description. So in this case, SmartTeam has found 11 documents. Now Joe can use the SmartTeam menu to look at those documents to find out any attributes or additional information that's been associated with them, where used reports or what components make them up. He's also taking advantage of the preview so he can see exactly what that component is. Once he finds the component, or in this case the assembly that he's looking for, he can ask SmartTeam to retrieve that right into SolidWorks for him. That's the level of integration that you can expect with the third-party applications and SolidWorks. Now that that assembly is inside of SolidWorks, what we'd like to do is let's take advantage of that console cutout that we see in that assembly in the part that we're working on right now. Now one thing to remember is SolidWorks is a native Windows application, and when you work in the Windows environment you're accustomed to certain types of interaction, such as dragging and dropping. And that's exactly how Joe copies that feature from one part to another. Notice the preview that SolidWorks gives you, so you see exactly what that feature is going to look like on the part before you release the mouse. And Joe has the ability to drag that from face to face to position it anywhere he'd like. In this case, we're going to take it and we're going to center it on the front face on a lower portion of our design. Now remember what I said before. Any type of modification is fine at any time in the design process. And looking at this, we can see that the part is actually kind of tall. So we're going to modify that depth dimension and we're going to change it from 100 to 30 millimeters. And we can see that feature and any subsequent feature updated to reflect that change. The next thing we'd like to do is let's remove the sharp edges that exist within the part. So to do that, Joe's going to add a fillet feature, and he's going to start with this lower corner. Now we want to ensure that the fillet is the same in all four corners of our console design, so Joe is simply going to drag and drop that fillet from one corner to the next. And it's just that simple, again, because it's a Windows application. What Joe's doing right now is he's taking that fillet and he's dragging it onto the front edge of the part as well. So that this way everything is tied together right on the part. Now looking at the part though, we can actually see that fillet's pretty big. So let's modify its size, again by just double clicking on that feature. What Joe is doing right now is he's taking advantage of the fact that he can rename those features right in the Feature Manager design tree to give them a very descriptive name, such as the body, or the display, or in this case the fillet on the front face. Here he's modifying the dimensional value for that fillet, and watch as he quickly makes the modification and updates the design until he dials in the size that he thinks looks best. Now the console is looking okay, but you know we're back to this prismatic shape, so we want to dress this up a little bit. Okay, so let's talk a little bit more about editing the design in SolidWorks. Look over at the left-hand side of the screen at the Feature Manager once again. The bar running across the Feature Manager is called the rollback bar, and as Joe scrolls that up and down, watch what happens to the graphics window. You can see Joe is stepping through the modeling of that part, and he can do that one feature at a time, or he can drag entire sequences. Wherever he puts that rollback bar, any feature he now creates is going to be created in that location in the history. So he started by adding a draft to lift up that face so the person riding the exercise machine can see it a little bit better. The next thing he's going to do is he wants to add curvature to that front face. So here he's going to use the dome function. With this function, Joe can add curvature to that front face, whether he wants to make it convex or concave, and he can control the magnitude of that as well. And again, just like all the other features that Joe creates in SolidWorks, he can take advantage of that preview. So he has a very good sense of what that looks like before he accepts the value. Now that's actually a little bit drastic, so let's go back and just make that a little bit more subtle. Okay, and again, Joe can edit this feature just like any other at any time in the process. Now that Joe's added the draft and the dome feature, let's go back and bring back the features that Joe created earlier. Again, as he takes that rollback bar, in this case he's scrolling it down, you can see those features come back. Let's just take the rollback bar and let's just drag it down to the bottom of the sequence so we can see the entire list. Now when that happened though, you can look over in the Feature Manager and you can see one of the features has a red exclamation on it. That means there's something wrong. So what Joe's able to do is he can select on it with the right mouse button and go to the What's Wrong menu option. When it comes up, it's telling him that one of the edges that was filleted has gone away, and that's because we domed it away with the dome feature. Well, that's fine. One of the ways we can fix it is to simply grab the feature from the Feature Manager design tree and drag it right onto a brand new edge. So now you can see that front face is now filleted just as it was before, okay? And the red exclamation is now gone in the Feature Manager design tree. And again, that type of editing your design is that simple in SolidWorks because it's a native Windows application. Let's talk about annotating your design. Normally, you create a 2D drawing to specify things such as surface finish, datums, tolerances. But one of the things that we want to do is we want to give people the option to work in a paperless environment. So what Joe is doing right now is he's annotating directly on a solid model. In this case, he's specifying datum features right on the part. Watch as Joe drags the datums around. They behave or react exactly the way you'd expect them to. Another thing we do to keep the display very clean is any face that's annotated, that's not shown, okay, that particular annotation will disappear to keep the display very simple for you. Another thing we'd like to do is we want to specify the material or give some additional information about the material that's being used on this part. And again, Joe's going to take advantage of the fact that he can add annotation to it. So what he'll do here is he's going to add a note, but not just any note. Joe's going to use the option to define a hyperlink, just like you expect to use when you're working with web pages, to not only give it textual information, but to point some information, whether it's somewhere within the company network, on your own hard drive, or maybe across the internet. And what he's done here is he's created a hyperlink that points to the web page for a plastic materials manufacturer. So when he selects on it, it brings up the web page for that manufacturer. Okay? So now it's just not a sentence or a paragraph, it's any wealth of information that you want to associate with the part. Now, since we're on the subject of annotation, let's take this part and create a 2D drawing from it. Again, because detailed drawings are still a very popular way to communicate designs within companies and between companies as well. So what we're going to do here is let's take advantage of that solid model that Joe's created to have SOLIDWORKS help us build the 2D drawing. So Joe's going to start with a brand new 2D drawing, and he's going to drag and drop the part right onto the drawing sheet. It's going to give him a front, a top, and a right-hand view automatically. It understands that these views should be projections of one another, so they stay lined up. It's even done the hidden line removal for him. The next thing we'd like to do is let's take a section right through the middle of the part. So Joe's going to sketch a section line right on the drawing view. Watch as the sketching tool helps him center that right on the part. When that's done, SOLIDWORKS automatically creates a section view for him because it understands everything about the geometry, even where the material is. Joe's going to add one more view to this detailed drawing, and this will be an isometric view. This is a great thing to have on your drawing because it gives you a good sense of what the part truly looks like rather than trying to interpret a set of orthogonal views. Now, we'd like to start dimensioning this. We have a number of different options available to us when we do this. What Joe's going to do is he's going to show the feature dimensions that were captured as Joe was constructing those features. We can access them either in the graphics window, or what Joe's doing right now is he's using the feature manager design tree to directly access certain features in certain views. Okay? And it's just a great part or feature of the user interface. So in this particular case, he's shown the dimensions for that display cutout that he dragged and dropped from the previous assembly. Joe has the ability to drag the dimensions around and modify the values or delete them without any special commands because, as you see here in SOLIDWORKS, it's just standard Windows interaction. As I'm speaking, Joe's going to continue by dragging the dimensions around and showing you dimensions in other views. To move dimensions from one view to another, again, it's simply a drag and drop from one place to another. We're going to continue looking or adding dimensions to the detailed drawing. Here in the top view, not only are we going to add dimensions, but let's add some of those datums that Joe added to the part when he was doing the 3D annotation. And again, he has the ability to drag these around anywhere he sees fit. Now, one thing to know about SOLIDWORKS is it's a fully associative system. And what that means is a modification made to any aspect of the design, whether it's in the detailed drawing, the part, or the assembly, and now in the third-party applications, and you'll see more of this later on in the demonstration, is all fully associative, so that modification will basically trickle down throughout all the other deliverables. So we're looking at our part, and we've been told it looks a lot like Rosie, the robot from the Jetsons, so we want to make some dimensional modifications so it looks a little bit more serious, because this is a serious exercise machine. What Joe's doing right now is he's changing the curvature of that dome feature by modifying its dimension. He's also changing the top height of that to make it a little bit shallower. When he makes that dimensional modification, watch how all the views in the detailed drawing update to reflect that change. And that change doesn't stop here in the detailed drawing, it's reflected everywhere. As Joe returns to the part, you can see that's been updated as well. And you'll see more of this associativity as we go through. But the important thing to note here is that every aspect of the design is in sync and up to date. Nothing is ever out of revision. Now what we'd like to do is let's take this console front that Joe's been modeling and let's add it to our assembly. Before we do that, okay, Joe's going to use our large assembly management tools, again called configurations, to simplify the assembly. This way we're going to zoom in or zone in just on the console area of our design. And this is the faster way to interact with the design by getting rid of components we're not really interested in at this particular time. So like I was just saying, let's take that console now and let's drag it into the assembly. Now that it's in place, we have the ability to drag it around with the mouse dynamically or to rotate it. This gives us the ability to coarsely place it in the assembly. But to place it more intelligently, with meaning, what Joe's able to do is define something called mating relationships. So he can tell SOLIDWORKS how one component is going to relate to another. So as one moves, the second moves right along with it. So what Joe's going to do is, let's start by taking the bottom edge of the console and let's locate it a particular distance away from the bookrest that you see there in the design. Once he's done that, you'll notice he still has the ability to dynamically rotate that around. He can pivot it and he can slide it back and forth. Let's do this. We don't want it to slide back and forth, so let's define another mating relationship to center it on the book reader in our console. Once Joe adds this mating relationship, what you're going to notice is Joe still has the ability to pivot this back and forth. So let's dynamically pivot that so the console is more or less facing right at the person writing on the exercise equipment. Now, Joe's been working in a bottom-up assembly mode. He's created a brand new component and added it to the assembly. What about those situations where you want to create a brand new component and ensure that it's the right size and shape to accommodate the other components that it's interacting with? Well, that's called top-down assembly design, and you have both options available to you in SOLIDWORKS. Let's create the back half of this console in the context of this assembly. We want to ensure it's the right size and shape to follow the console that Joe's been creating so far. So Joe's going to create a brand new part, and he's going to insert it right on the back face of the console he added to the assembly. He's also going to take the profile of that particular part, and he's going to copy those edges into a sketch. That sketch is now going to be used to create the profile for the back console. Now, in doing that, Joe has the ability to extrude that a particular depth, just like he did earlier, but let's do something even smarter. With our features, you can give them particular types of behaviors. The behavior that Joe's going to use right now is something called up to surface. And he's going to select a surface on that diagonal bracket in the back of the console. When he does that, watch what happens when he creates the feature. It knows to stop right on that face. Not only now, okay, but with any modification he makes to the design. And you'll see what we mean in a moment. We want to fillet those back edges and get rid of that sharp corner. We want it to be the same size as the front of our console, so let's simply drag it from one component and drop it right onto the other, the one that we're working on. And again, let's take a look at the benefits of the top-down assembly design that's available to us. Joe's going to go back and he's going to modify the width of this console display. Right now in the assembly, we're working in inches, but you know what? We know the width should be 375 millimeters. This is a minor point, but just something to make things a little bit easier for the user. He was able to type in 375 mm, and SOLIDWORKS does the conversion for him. When he says update, watch what happens to the front console and the back. What you're going to notice is the back is going to update right along with it. So as the front console changes size, the back is updating accordingly. And it's not just the profile or the size that's going to change. Let's say we've done some tests and people don't like the fact that the display is facing into their chest, so we want to tilt it back a little bit. So again, Joe's going to use dynamic assembly motion to take the console and dynamically pivot it back. But remember, when we constructed the back half of the console, we extruded up to that bracket. When Joe says update, watch what happens to the back. What you're witnessing is the benefit of top-down assembly design and the fact that SOLIDWORKS isn't just creating geometry, it's capturing the design. So as you make modifications, SOLIDWORKS is going to do a lot of the tedious work for you when it comes to design change, as you see here. Now let's say we work in a concurrent engineering environment and we want the tool designer to have an opportunity to start working on the mold for this console while we continue on the design. So what Joe's going to do is he's going to bring up a mold base. Okay? And these are all the plates that make up a mold, okay, when you do injection molding. He's going to explode that so you can see all the components that make it up. But let's do this. let's just take the top half of that mold and drag it up with dynamic assembly motion so we can see the plate that we're going to machine a cavity into for this console that we're working on. And the thing is, we talked about associativity before, the fact that a modification made in one place will update in another. We want to get that same level of associativity between what the tool designer does and the design engineer. So Joe's going to start by taking the console from the assembly and he's going to drop it into his mold base. Let's locate that console into the center of that mold plate. So again, Joe has the ability to dynamically drag it around in space, and then he's going to nail it to the very flat surface of that mold plate by defining a mating relationship. Now that that's in place, we want to edit that place while we're in the assembly, and we want to define something called the cavity feature. Just so it's a little bit more obvious what's going on in the design, Joe's going to bring up that plate that he's working on right now in its own window so you can see what happens as he adds the cavity feature. So what Joe's going to do is he's going to select the console part that he's working on right now, and he's going to specify a shrinkage value, because again, there's shrinkage involved in molding, and he can specify that in this dialog. And faster than I can ever say it, SOLIDWORKS just created the cavity for him. And again, it's fully associative, and you'll see what we're talking about in a little bit. Again, since we're working in this concurrent engineering environment, maybe we want the manufacturing engineer to have the opportunity to start generating toolpaths right on the part. So again, let's take advantage of an integrated solution partner application. Okay, in this case, Joe's going to use SurfCAM to do 3-axis milling right within the SOLIDWORKS environment in an associative manner. So without ever leaving SOLIDWORKS, he's going to do things like select the appropriate size tool to machine out this cavity, specify a step over and any other machining properties, and we'll point out that we do recognize that you would never generate this cavity in one machining operation, but we're just doing this for time's sake. So what SurfCAM is doing right now is it's directly reading the SOLIDWORKS geometry and generating a toolpath. There's no IGES or any type of conversion that's necessary because this is a fully integrated application that's using the SOLIDWORKS API. And now we can see a toolpath has been generated to follow the exact contours of this mold cavity. We'll return to this in a moment. Now let's say, as the tool designer and the manufacturing engineer has been doing their work, Joe's continued his work on the console part in the assembly. What we'd like to do is, we've looked at the design, we have this great shaded representation so we can evaluate how it appears. Maybe we don't like the fact that the shape is convex. We want to make it so it's more concave and give us more of a wraparound feel in the design. So Joe's going to go back and he's going to edit the dome feature that he was working on before. Again, he can control the magnitude of the curvature, and not only that, but the direction that it curves in as well. When Joe has a shape that he's satisfied with, he's going to update the dome and all the subsequent features associated with it. And that update doesn't stop there in the assembly. The part has been updated, the detailed drawing has been updated, but when Joe returns to the mold base, watch what happens, especially in the lower window, okay, when we talk about the cavity part. You're going to see the curvature of that's been updated as well, based on the modification that Joe just made. And what about the manufacturing operation? Remember, Joe generated that toolpath with not a SOLIDWORKS application, but an integrated third-party application. But you know what? Those are fully associative as well. So as he selects on it with the right mouse button, you'll see he has a regenerate toolpath option. What SurfCAM is doing right now is it's reevaluating the SOLIDWORKS geometry that it machined earlier. It's found out that there's a change, and it's now generating a brand new toolpath based on the modification made there. And when it's done, you're going to see the toolpath follow the brand new contour created by Joe. Now, so far in the design, we've been focusing on the console area. Let's just step back for a moment and look at the entire Crosstrainer. Okay, we want to look at the motion that's generated by the mechanism inside of our Crosstrainer. One thing that's very important about this motion is it's got to be an elliptical path because this is a zero-impact exercise machine. What Joe's going to do right now is he's going to use our large assembly management tool, configurations, to bring back the entire assembly so we can look at the overall design, the outer shroud, the internal mechanisms, the step or the pedals for the design as well. Let's go ahead and let's turn off the side shroud so we can see the mechanism inside. Now to do that, one of the things that you can see is there's crank arms and pivots associated with the inside of the mechanism. What Joe's doing right now is he's going to use dynamic assembly motion, like he's been showing you earlier when he was moving the console around, to actually move this mechanism through its paces. So as the crank is spinning, you can see the pedals move, the arm exercise bars moving as well, and you can see the complete interaction of all the components inside of the design. Now, one thing that should be noted is this is not a replacement for a kinematics package. SOLIDWORKS enables us to see how the components are going to move relative to one another, but it doesn't give us any information at all about forces, accelerations, gravitational effects, or anything like that associated with the true design. To do that, you need a true kinematics package. What Joe's doing right now is he's turning on annotation, okay, the same 3D annotation he showed you earlier. And what he has here is a hyperlink to a kinematic analysis performed on the entire Crosstrainer design. In this particular case, the analysis has been done using working model. Here they can specify, again, everything from kinematic analysis, forces exerted by the person pushing down on the pedals, and anything else associated with the design as it's moving. As Joe runs this analysis, watch the machine goes through its motion. You can see the elliptical path that's generated on the pedals. But most importantly, on the right-hand side of the screen, you can see the graphs representing the forces that are generated on any particular location within the design. In this particular case, we're looking at the forces generated on the crank arm. Here, we can see we have a general force of about 600 pounds at the very end of that crank arm. Let's take this information that's being generated for us by working model, and let's use it to perform a finite element analysis right on our design. So Joe's going to start by bringing up that crank. And again, let's take advantage of fully integrated third-party applications. In this case, we're going to do a finite element analysis right inside of SOLIDWORKS. Joe is going to start by defining loads and boundary conditions and materials on the part. I think we're going to start with the default material of steel. Next, we want to apply loads and boundary conditions to the design. What Joe's going to start by doing is, let's fix the bottom end of the crank, or that hole, through its center. Next, Joe's going to apply a force to the end of the pin, and this is going to be 600 units of force that he received from working model. Now, one thing to know about these loads and boundary conditions that Joe's applying is they're, again, fully associative. As Joe continues to make modifications to the design, none of the work that he's specifying right now is lost. So if he needs to reanalyze, he can basically maintain that information. What Joe's doing right now is he's showing you the results of a post-processed analysis. And one of the things that we find out, based on this analysis, is the part is over-engineered, or it's a lot stronger than it really needs to be. Maybe we want to get or strive for a more optimal design that's lighter, okay, yet strong enough. So what Joe's going to do is he's going to add a cut feature right through the center web of this crank arm. To do that, he's just going to create another SOLIDWORKS feature by sketching on that face and doing a through-all cut. Let's take this part now and reanalyze it based on the modification that Joe just performed. And again, is fully associative. He doesn't have to re-specify the loads and boundary conditions of the materials that he specified earlier on the part. With that, we can see the new analysis results right on the modified part. And based on the contour plot that we're looking at, we can see that this is more of a true optimal design based on the weight that we're able to retrieve and the stresses that we can see in the design. What Joe is generating right now is an animation of the analysis results. This way we can see exactly how the part is going to behave or react as the load is being applied to the part. And the great thing is, all this is being done right within the SOLIDWORKS environment without any data translation or anything necessary. This level of integration that you're seeing in SOLIDWORKS was only possible in the past when you purchased everything from one vendor. But thanks to the technology today, and primarily Windows and the standards associated with it, you can get this level of integration right within your engineering environment. What Joe is showing us right now is, thanks to the associativity as well, the crank arm has been updated in the assembly, right along with the designed part. We want to finish our demonstration by bringing up a web page for Life Fitness. Now, this web page is a marketing web page, and it has information associated with it, such as where you can buy it, who the dealers are, what gyms use their equipment. But what Joe's going to do is he's going to go to a tab called Technical Publications. And this is going to bring up a Microsoft Word document. And what you're going to notice is Microsoft Word is going to be running inside of the Internet Explorer. What you're watching right now is a Microsoft standard called ActiveX. And what it does is it gives you access to various documents or files that you can create on your Windows environment anywhere, whether it's on your intranet within your company or on the Internet. So as you can see here, Joe's looking at the Microsoft Word user interface inside of the Internet Explorer. But it doesn't just stop there. The image of the Crosstrainer that you see inside of Microsoft Word, if Joe double-clicks on this right now, what you're going to notice is ActiveX works just as well within SolidWorks. So think about it. Joe has SolidWorks running inside of Microsoft Word, which is inside of the Internet Explorer. That's the level of integration that's possible in the Windows environment, because all these applications can work with one another and speak the same language. Joe is now able to make any modification he wants in the design and have that reflected in the Word document and enhance the Internet or the web page. We hope you agree that SOLIDWORKS 97 is the new standard in Windows-based solid modeling because it's a production-level solid modeling tool. It had the ability to create very sophisticated parts completely so you could use them in downstream applications that are fully integrated in SolidWorks. 2, it's a native Windows application. So not only is it a familiar Windows user interface that's easy to use, but it also helps engineers to communicate their designs to others thanks to standards provided by Windows. And we've priced it so that every engineer and designer can take advantage of this functionality right on their desktop. Thank you for your time.